Okay, so in this question, we are given our matrix A, and we're asked to use the inverse of A to solve this following system of linear equations. Now to find the inverse of A, we're going to use 4 steps. The first one is to find the matrix of minors, then the matrix of cofactors, then the adjugate, and lastly we are going to multiply the adjugate by 1 over the determinant. And that is going to be our inverse. So let's just go ahead and start with that. We have a matrix A, which is 4, 2, 1, minus 3, minus 3, minus 1, 3, 2, 1. To find the matrix of minors, we're going to start with our top left number, cross out its column and its row, and just rewrite everything that's left over. So we have minus 3, minus 1, 2, 1. For the second one, we cross out its column and its row. We have minus 3, minus 1, 3, 1. Then here we cross out this column, this row. We have minus 3, minus 3, 3, 2. Now for the second row, cross out this row and the first column. We have 2, 1, 2, 1. For the middle one, cross out the middle column, middle row. 4, 1, 3, 1 is what's left over. Now for here, cross out this and this. We have 4, 2, 3, 2. Lastly, cross out the last row, first column. We have 2, 1, minus 3, minus 1. For the second one, we have 4, 1, minus 3, minus 1. And then 4, 2, minus 3, minus 3. To find the actual matrix of minors, we need to take the determinant of every single one of these 2 by 2 matrices. So if we remember how to do that, we multiply this diagonal minus the multiplication of these 2 numbers. So here we have minus 3 times 1 minus negative 1 times 2. So negative 3 minus negative 2 is negative 1. Now for this one, we have negative 3 times 1 minus 1 times 3. So negative 3 minus negative 3, which is 0. Now negative 3 times 2, which is negative 6, minus 9. We're left with 3. And we have 2 times 1, which is 2, minus 2 times 1, which is 2, and we're left with 0. 4 times 1 minus 3 times 1, 4 minus 3, which is 1. 4 times 2 is 8, 8 minus 6 is 2. 2 times negative 1 is negative 2, minus negative 3 is equal to 1. 4 times negative 1 is just negative 4, minus negative 3, which is negative 1. 4 times negative 12, last one, is 4 times negative 3 is negative 12, minus negative 6 is negative 6. So we are done with our M, because that's what this is. Now the next thing we're going to do is we're going to multiply our matrix of minors by a matrix with this form. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So what we get is positive 1 times negative 1, which is still negative 1. Negative 1 times 0, which is 0. Positive 1 times 3, which is 3. Negative 1 times 0, which is 0. Positive 1 times 1, which is still 1. Negative 1 times 2, this changes to negative 2. Positive 1 times 1 is 1. Negative 1 times negative 1 is 1. Positive 1 times negative 6 is negative 6. So this is our matrix of cofactors. Now the last thing is to find the adjugate before we figure out what our answer is. To do that, we're going to switch these two up, and switch these two up. So we leave our middle diagonal as it is, and it's like we switch everything that's on the bottom to the top. So what we're left with here is -1, 0, because we're switching these two. Switching 3 and 1, so we have 1. 0 switches with 0 is 0. 1, now 1, because we're switching these two. Switching 3 and 1, so we have 3 here, -2, and -6. So this is our adjugate. So to find out what the inverse of A is, we need to figure out what the determinant is. And we're just going to use Sauer's rule for that. So we have 4, 2, 1, -3, -3, -1, 3, 2, 1, and we're going to expand that. So take the first two columns and rewrite them. 4, 2, -3, -3, 3, 2. We're going to draw some diagonal lines. So we have 3 times -3, which is -1. -9 times 1, which is -9. Here we have 2 times -1 times 4, which is -8. Then we have 1 times -3 times 2, which is -6. Now for the side, we have 4 times -3, which is -12 times 1, still -12. 2 times -1 times 3 is -6. 1 times -3 times 2 is -6. So now let's add up the bottom. So we have -12 minus 6 minus 6 is equal to -24. And then we have -9 minus 8 minus 6, which is equal to -23. Then we do -24 minus -23, and we are left with -1. Then we do 1 over -1 multiplied by the adjugate, and that is going to be our inverse. So basically we're just multiplying everything by -1. -1 times -1 is 1, 0, -1 times 1 is -1, 0, -1, -1, -3, -2 times -1 is 2, -6 times -1 is 6. So the last step of this problem is to figure out what the solution to the system is. So here we can rewrite this set of linear equations. We have 4, 2, 1, -3, -3, -1, 3, 2, 1. And we can see here that this is in fact our original matrix A. Now we can do X, Y, Z here because this first column is X, this is Y, and this is Z. And all of this is going to be equal to -3, -9, 2. So if we were to look at this another way, we actually have AX is equal to B, and we want to figure out what X is. So if we take our A and we do an inverse of that, so we do X is equal to the inverse of A times B. So all we have to do now is take our inverse of A and multiply it by B. But remember, it's a matrix multiplication. So here we're going to have the inverse of A, and we are going to multiply it by B, which is our answer matrix. So we have -3, -9, and 2. And if you remember how to do a matrix multiplication, we're going to take the first row and the first column. So we're going to do 1 times -3, which is -3, plus 0 times -9, which is 0, plus -1 times 2, which is -2. Then we're going to take the second row and the first column. 0 times -3 is 0, plus -1 times -9, which is 9, plus -1 times 2, which is -2. And lastly, we take the last row, do -3 times -3, which is 9, plus 2 times -9, which is -18, plus 6 times 2, which is 12. And now our final answer after doing all of this is going to be -3 plus 0 plus -2 is -5. 0 plus 9 minus 2 is 7. 9 plus -18 plus 12 is equal to 3. So our final answer is x is equal to -5, y is equal to 7, and z is equal to 3.